This is the fifth in a series of videos on the subject of configuration management, or CM, designed to provide a grounding in the subject and to allow those of you who are either about to start doing development or have recently started to understand what it's all about and how important it can be to projects. In our last video, we looked at automated build processes and how modern CM tools can be used to do both planned and continuous integration builds. Now it is time to look at how we test the output from these builds by looking at the activities of the test or quality assurance team. Hopefully, you're not asking the question, why bother testing? Why not just send the release out now? While developers have done unit testing on the project, this has only tested parts of the project in isolation. We need to do a full system test to ensure that all the changes work together, with the code that hasn't changed in this release, to deliver the requirements needed. The amount of testing done by the testing team is directly proportional to the complexity of the product or system, and the number of requirement changes since the last release. Traditional testing was all done by hand, with testers stepping through all areas of the product on screen and comparing what they see against what is expected from the requirements. However, modern testing is likely to rely heavily on automation, via a range of testing tools that support testing scripts, to both check new features and regression test those features that should not have changed. While the creation of these testing scripts used to be a manual process, the use of AI and machine learning is now making inroads to streamline the process. Testing will go through a series of stages. Installation. Will the software successfully go through an upgrade process without generating errors? New functionality. Confirmation that each of the request for change, or RFC, entries in the requirement or issue management systems matches what is observed in the updated system. Regression testing. Does the existing functionality that shouldn't have been part of any changes still work as expected? Should anything unexpected be discovered, then this is an issue. For any of the RFC entries that have generated errors or not behaved in a way that matches the requirement, then the entry in the requirement or issue management system will be marked as failed testing. For all other errors, a new entry ticket can be raised. For all such entries, you should expect the addition of details of any relevant screenshots or log files, plus the details of the path taken, the 1, 2, 3, to get to the point where the error occurred. This is all very valuable information for the development team to allow them to reproduce the error in their development systems. If they can reproduce the error, then there is a better chance of them being able to correct the problem quickly. So during the testing phase, the testing team may generate a number of these issue tickets. Should no errors be found, then all the RFC entries can be marked as passed testing. Like development work, entries in the requirement or issue management systems extend the workflow from passed to testing, through in test, to tested, or failed testing. Assuming your product or system gets through the testing phase on the first try, that is a major win, and the project manager will be having a really good day. However, you should expect and plan for more than one iteration of the testing phase. Once an iteration of the testing phase has been completed, with one or more entries marked failed testing, the system or product is passed back to the project manager to initiate a rework phase. Project managers should have already built in a contingency to their project plan to cater for the possibility or likelihood that rework will be required. However, next we will look at just how a development team will cope with this rework phase of the project. Rework. After completing development, the development team will have moved on to start work on the next time box or sprint, and its collection of requirements. This will mean that they may well have already started to change code that was part of the previous time box. So how will they handle fixing the problems encountered in the first time box's testing? This is where your version management system, the VMS, comes to the rescue. VMS systems differ in just how they handle this, but the basics are as follows. When the version of the product was passed to testing, all the files of all the deliverables that were used to produce the project at that point in time are grouped together to allow them to be singularly identified. This can be referred to as branching, and this branch of the code is labelled, for example, build version 1.2.1.6. When the developers start working on the second time box, they will be working on another separate branch that will have as its baseline the build version 1.2.1.6 branch. So the VMS has two independent sets of code, one for the build and test, and one for the next time box's development. The build version 1.2.1.6 branch is pristine and not touched by the second time box work. The development for the second time box could be working off a branch called development 1.2.2.0. So when the part of the development team tasked with the rework phase of the first time box need to make changes, then they will be made to the build version 1.2.1.6 branch. This will, as before, go through the unit testing and automated build cycle once more, becoming build version 1.2.1.7, and will again be passed to the testing or quality assurance team to check. This cycle repeats until the testing team agree that there are no more problems, and the rework phase ends and this build becomes a release candidate. However, since changes have now been made during this rework phase, then these changes will need to be merged into the development 1.2.2.0 branch that the rest of the development team are working on, to ensure that the errors encountered in the first time box do not reappear in the testing of the second time box. This merge phase is critical, and again needs to be factored in by the project manager and their team into the timescales of the project. So now that we have a release candidate, the packaged product can be rolled out to the production or live environments. However, it's very common to either do a limited release to beta users or go through our formal user acceptance test phase for large critical projects. This will help to ensure that users themselves can confirm that the functionality they require is actually in the product. Should the users discover something in the product that is not as expected or wanted, then the project goes back to be reviewed and then possibly another rework phase. Modern methodologies like Agile and DevOps tend to go through smaller, rapid release cycles and iterative development to ensure that problems are caught earlier, and that in large corporate developments, the users are more involved in the whole process. As you can tell, the process of development in a large and complex project with many developers can be complex. But this is made possible by modern configuration management tools, which provide the clarity needed to succeed. In the next video, we will look at the work of the support desk and how incidents, issues, and problems are handled. But that's it for today. Thank you for watching.
Thank you for watching today's video. please feel free to click on the link in the description below to discover more videos.